Okay, so I've got practice problems ready. I've got a list of topics. It's just the last kind of problems that I might have to make up the numbers, but we'll get a practice, like, we'll practice the idea for sure. This would be review 2. Part 2. So I'm going to start with going over what's important, or like what you need to focus on from chapter 17. And then we'll go and do examples from both chapters. Okay, the chapter is about the normal distribution. And we started with a random variable, which we call capital X. As a normal distribution, if it's, no, we're going to talk about that later. X is a measure of each outcome from an experiment.
Are we kind of doing the same format as review on Tuesday, giving like the list of topics and then doing examples accordingly?
Yeah. That's the plan.
Awesome, thank you.
Okay. Outcome from an experiment. Continuing. All right. Then the mean for X is mu sub X. And there's a formula for mu sub X. It's equal to the sum of X times P of X. So multiply all of the X's with their probabilities and then add everything together. Okay, so mu sub X is equal to the sum of X multiplied with P of X.
Professor, like in the exam, when we're answering like, I think there's like 2 or 3 questions regarding like mu sub X, mean of X. Are we sufficient by just saying like mean equals, and or like do we not have to worry about like going and like copying pasting like mu from some, you know what I mean? Like,
Oh yeah, even
can we just say
just
mean of
number.
X, or do you want us to like find? Okay,
Yeah.
just enough. Okay, cool. So we don't have to stress about finding a source where we can copy mu.
Yeah, you don't have to find the symbol. I know it's difficult to type up your answer. But also what you said is fine. You can put the word mean. Yeah, if you just work out what the
Perfect.
number
All right,
is,
cool.
I'll have to update.
Awesome. All right, thank you.
Yeah, for sure. Today's the day to ask questions, so don't hesitate. Mean, and then I talked about, so a little transition. So not all experiments have a normal distribution, but a lot of them do. So that's kind of why I decided to focus on this chapter. So since many distributions have a histogram that is bell-shaped, okay. So it's a bell-shaped distribution, which means it's a normal distribution. Okay, again, we'll practice this. The mean of x is x times p of x. And moving on. Many distributions have a histogram that is bell-shaped, which means many distributions are normal. And normal is like the name of the distribution. It's normally distributed or has a normal distribution if its histogram is a bell shape. Okay, so let's draw a picture. Along. The other side matches. It's a symmetric graph. Okay, the tails never cross the x-axis. So these are your x values. The mean is in the center. We're centered at the mean. Okay, and then if you go one standard deviation to the right, you meet an inflection point. That's this spot right here is the mean plus sigma. And then the same on the other side. So if you go one standard deviation to the left, that's right at where an inflection point would be. Okay, right there is mu subtract sigma. So we put that up. The distribution, the normal distribution. Centered at the mean. And has inflection points at mu sub x minus sigma and mu sub x plus sigma. Okay, that's it. Then we talked about the area under the normal distribution. That area is equal to the probability of observing x in that part of the distribution. Okay, so again, normal distribution is centered at the mean. We'll practice using the inflection points to find sigma. Either one of the inflection points. We'll practice that later. Okay, the area under the normal curve on an interval. Is equal to, we're just going to do an equal sign. This area equals the probability of observing x on the interval. Observing the random variable. Interval. Make it work. Nope, we're going to put it at the top. Okay, so hopefully you've gotten the first part. The area under the curve, the normal curve, on an interval equals the probability of observing x on that interval, the same one, in the same place. put one more note and then we're going to go through a bunch of examples. We can still use the complement rule for something that looks like probability of the random variable x being greater than a number. We're going to call the number a. So a is a number and x is greater than a. We can take this and use 1 and subtract the probability that x is less than a. And I've mentioned before, having this equal sign here or not doesn't change the overall area. So you can have it strictly less than, you can put less than or equal to. The main thing is that you flip the sign. Okay. Okay. I'm going to try to set a timer. And I think we'll get through everything. So we have one more example to do from chapter 16. I don't remember what number it was. I think we want to do one more table. Consider the data table. It will have X, Y, and then on the top, A, B, C. Right. The numbers are 4 and 3. Total right there would be 7. Event B has 6 and 5 with 11 total. Event C has 5 and then 3 makes 8 total. And the full space will get the total across this way, which would be 19 plus 7 to go to 26. And then the totals that way. 4 plus 6 is 10, 5 more, 15. 8, 9, 10, 11. And then this gonna double check this total is 6 and 2. Cool. So that's the size of this full space. This is the number of elements in S. First part, let's find the probability of A. Okay, the total number of elements for A is 7. Divide by the total number of elements from the space, 26. Find the probability of A complement. Where can we, let me just have to erase. All right. So number 26. Number 2. Okay. Use 1, subtract probability for A. 1 and subtract the 7 over 26. So we'd have 17, no, 19 out of 26. I'm also looking at another way of doing the problem. Let's see if I can find this. So the probability of not A, we could block out A and find the probability of the rest. The total for B, add to the total of C, divide that by the total for S. So it should be 19 out of 26, but we'll make some space for scratch work. Okay, so that would be 26 over 26. 7 out of 26. 26 subtract 7. We'll go to 19. Kind of need the table to help show where the numbers come from. So let's I'm gonna redraw it. It'll just be like a moment, but it'll help the rest of the problem. Let's go to the corner over here. No, that was a 26. There was 437. Okay, that's better. Number 3. Find the probability of X. So the number of outcomes in X is 15. Then divide by the total number of outcomes in S. Number 4, we're going to find the probability of the complement of X. Probability for X complement is 1 subtract probability for X. 1 minus 15 over 26. Out of 26. Subtract 15 out of 26. So I'm looking at 11. Yep, 11 out of 26. So I was using the table for a moment to check that I did the problem correctly. If you're looking at the complement of x, so block x, the leftover total is 11. 11 out of 26. Okay, let's find the probability of A intersect X. So we have to find where A intersects X. A is going this way, X that way, and the intersection's right there. Out of 26. Let's see, let's reduce this really fast. This is 2 times 2 over 2 times 13. So the 2 over 2 is going to reduce to 1, and you have 2/13 left over. Number 6. The probability of A union X. Okay, this is from the formula. We'll take the probability of A, add the probability of X, subtract probability for A and X. The first part is 7 out of 26. Probability for X is 15 out of 26. And then the probability for A intersect X is 4 out of 26. Let's put everything over 26. All right, 7, add 15, subtract 4. So this would be 11. 7 plus 11 is 18. 18. And double check. Let's go with 22, subtract 4, 18. Okay. Let's do another problem that's like practicing the union of two sets. Let's find the probability of the union of B and Y. Number 7? I think it's number 7. probability of B, add the probability of Y, and subtract the probability of the intersection of B and Y. Probability for B, let's go get 11 and divide by 26. Probability for Y, so find Y, go over to its total. Oh, interesting, 11 out of 26. Okay, subtract the probability for B intersect Y. So on this set B, and intersect with Y, right here. Okay, we need to subtract 5 out of 26. Out of 26, we have 11 plus 11 minus 5. 22 minus 5. So 17 out of 26. Okay, I think we should start working on chapter 17. So the first thing we'll do is find the mean for a probability distribution. Find the mean of the following distribution. Okay, we're going to go x and p of x. Put 1, 2, 3 for the x values, and the probabilities are 0.7, 0.2, 0.1. The mean is equal to the sum of x is p of x. So I'm going to start with putting in x values. So 1 times p of 1 plus 2 times p of 2 plus 3 times p of 3. And then we'll go on and put in all the probabilities. One times 0.7. Add 2 times 0.2. And then add 3 times 0.1. Cool. And we're just going to work it out. So 0.7. This would be a 0.4. Also, let me know if I make a mistake. Cool. And that's 0.3. Okay. So 0.7 plus 0.3, that's going to be 1. And then add 0.4. So we got to 1.4. Okay, number 2. So we're just going to say find the mean of x. On the side, there's a table with x values being 0, 2, 4, 6. Okay, probability for 0 is 0.3. The probability for 2 is 0.2. Probability for 4 is 0.4. Last one is 0.1. All right, the mean for a random variable is the sum of x times p of x. So we're putting in 0 times p of 0, add 2 times p of 2, and keep going. The next one is 4, so put in the 4 times p of 4. Last one 6 plus 6. P of 6. Put in each probability. All right. 0 times 0.3 plus 2 times 0.2 plus 4 times 0.4 plus 6 times 0.1. simplify, this part is a 0. This would be 0.4, and then add 1.6. We'll double check. 0.4. I think that's a 1.6 and add a 0.6. Let's check. And then add it all together. (1.6 plus 0.6 plus oh shoot 1.6 and a 0.4. I got 6.2.
Professor, I got 2.6. 0.4 plus 0.6 would make it 1.0 plus 1.6 would be 2.6.
Yeah, I think I missed a decimal. Thank you. 2.6. 2.6. Check it again. Cool. And I think we should try one more problem for finding the mean. So, find the mean. We'll get rid of this soon, but x, p of x. X is going to be 0, 5, or 10. And we're going to have 0.2. Let's do 0.4. 0.4. There you go. 0.4, 0.4, 0.2. Mean is your sum of x multiplied with p of x. So we're putting in 0, 5, and 10. 0, p of 0, add 5, p of 5, add 10, probably 10. 0 times 0.4 plus 5 times 0.4 plus 10 times 50. This first part is 0. 0 times the number goes to 0. 5 times 0.4 be 2. And then 10 times 0.2 would be 2. I got 4. Okay. Let's move on to finding the mean of a normal distribution and then also the standard deviation. from a picture. All right, we have a bell curve. Put over here. Okay, so in my pictures, I label the center and the inflection points. The center is also the mean. In this case, is 57. This will be 47, 67. The mean is 57. Whatever number that the distribution is has its peak at. Right. Standard deviation is the difference between 67 and 57. Okay. Standard deviation is sigma, and sigma is equal to 10. So find the mean and standard deviation. Okay, so this is a new problem. So it's a normal distribution. It's going over here, and it goes over this way like that. And it has a center at 34. Okay, the first inflection point is 32, and the other one is 36. So the mean is that number in the middle, 34. Standard deviation is also called sigma. And this time it's the distance from 32 to 34, which is 2. Cool. So now we're at the last kinds of problem on the test. So you're given area under a curve, and then we're going to work with everything after that. I kind of have to make up some of the numbers, so it won't be too specific, but we'll practice using areas under the curve. Okay. Steal from the notes. So this one we've talked about before, but we're going to use a different part of the problem. We had a random variable x, and it's normally distributed or has a normal distribution. I know, I'll just leave out some info sometimes, I think. Normal distribution. Okay, so this one, the mean is 24. Assume that the area to, let's see, the left of 26 is 0.56. Find the probability that x is less than 26. And in these kinds of problems, I usually gave a picture and labeled the part that was described in the problem. So x has a normal distribution with mean of 24. Picture looks like this. So that's the mean. The area to the left of 26, which would be 2 spaces past 24. On the left side, this way. Is 0.56. The probability that x is less than 26. So your x values are on this number line. And we go to 26 and below for x. So on that interval, the probability is equal to the area under the curve. So all you have to do is take probability for x being less than 26 and match it to the correct area. In this case, it's the one that you're given. Next one, let x have a normal distribution. Or we could say, let x be normally distributed. And the mean is going to be so the mean is 50, and I'm going to skip the part about the standard deviation and go into the probability that x is greater than 65. Is equal to 0.0162. Find probability that x is greater than 65. I mean, sorry, the opposite. So the probability of x being less than 65. So we're going to use the complement rule, but I want to draw a picture first. And we'll start with our normal distribution centered at 50. And after that, we'll shade. $65. So we've got x less than 65, which we'll start with 50, 60. And then we're going to mark 65 and find x values less than it. So this time it also goes to the left. Okay, for that interval, well, that's the interval we need. Okay, so we need the probability. We need the area under the curve. But I have to use the part that we have right here, probability for x being greater than 65. So this is at 65 and going to the right. Is going to be a probability or corresponding area of 0.0162. Cool. So take probability that x is less than 65. Use 1 and then subtract the probability that x is greater than 65. So it's this part here. We take the full area 1, subtract this piece, and it leaves the leftover area. All right, I need a calculator. Well, 1 minus 0.0162, I got 0.9838. And I think we can do one more problem. Oh yeah, So I'm going to use something that we've talked about in class before, but we're just kind of ask a different question. So let me find those word problems we did. Or make something up. I got one. Okay, let's make up this. Okay, I think we did something like this on homework. We'll say the number of the amount of time spent doing homework is normally distributed. Like, let me kind of steal from. Let's do like this. Like the time it takes to study for a test has a normal distribution. We're going to put a mean of, I'm going to say, I would say 4 hours with a standard deviation of maybe 2 hours. Okay, let's see. Let x equal the time spent studying. For an example. Okay, let's see if I can get this all. We've got a random variable, and then we want to talk about the probability that a student spends more than 5 hours studying for an exam. So I'm just going to do the math symbols. Probability that the time spent studying for the test is more than 5 hours. Okay, and then you'll have to give me a moment, and I'm going to find a little Google C-table calculator. Let's see. Thank you for being patient. I don't want to make up the number when I can just put it in a calculator. Awesome. Let's go. Let's try. Okay, so we want to go greater than this number. Okay. The results area is 0.3085. Cool. Okay, back to class. And let's draw a picture. So the center is 4. Our random variable is x. Okay, and then we're given the probability that x is greater than 5 is that number. So go over and mark 5. Next values that start at 5 and are greater than that go to the right. So I just did this part. And then the probability is the area under the curve above that interval. It is that number right there. And on the test, I've asked something like, find the probability of x being less than or equal to 5. What is less than 5? So it's that side over here. Your x values being less than 5 would start at 5 and go this way. So you want the unshaded area, which is 1, and then subtract 0.3085. Okay, this would be 1. The complement rule, take 1, subtract the probability of x being greater than 5. And that's that part. 1 minus 0.3085. Okay. Which is 0.6915. Where are we? There we are. Okay. Okay, that's the end of the review. And I think we're actually out of time for class pretty much. Yep, it's the end of class. So give the test a try. Let me know if you have any questions. And next week we start our last topic, which is called graph theory. I'm kind of excited about it, but we'll see how